welcome to Crystallink tutorials. Today we'll be looking at variation and the subject is still mathematics. So variation is another very important topic that find a lot of application not only in other topics in mathematics but also in other subjects like chemistry and physics, economics, yes. If you are not familiar with variation, trust me, you will always have issue with physics because all the laws in physics and chemistry, you need to apply the knowledge of variation to transform those statements, those theories and laws into mathematical equation. For example, we talk of Charles' law, Boyle's law, Ohm's law, Graham's law, and the rest. All these require direct application of the knowledge of variation. So that is why the topic variation is very, very instructive and very, very important. And good enough is not really difficult if you just give it a little time and little concentration. So what is variation? Variation simply tells us the connection between two quantities. Yes, say variation is a connection of set of numerical values by an equation. Now in practical sense, for example, what is the connection between let's say price of petrol and transport fare? So when there's an increase or decrease in the price of petrol, how does it affect transport fare? That is typical practical of variation. So typically, when there is an increase in the price of fuel, petrol, of course, you know that it stimulates an increase in transport fare. Yes, so that is variation. So uh, um, it's a topic that shows us how a change in one quantity causes a corresponding change in a related quantity. So that's what variation is about. Then you have four types of variations. Four types of variations, major types, of course, and they are direct. You have direct variation, you have inverse variation, joint variation, and partial variation. As I said earlier, direct variation, joint variation, and inverse variation, you come across it a lot in your physics and chemistry, as well as some topics in economics. For instance, if you talk of demand and supply in economics, yes, you find application of variation there. So let's go straight to look at the various types one after the other. So we start with direct variation. Direct variation considers a situation where an increase in one quantity causes a corresponding increase in another quantity. So increase in one causes an increase in the other one. And there are many real life situations where you find such relationship between quantities. As I said earlier, a typical example is the cost of petrol per liter and the cost of transport. So you notice that whenever there is an increase in the cost of petrol, it causes an increase in transportation fee. Also, it also causes an increase in some other basic items. So on your own, I expect you to figure out real life situations where an increase in one quantity stimulates a corresponding increase in another quantity. So let's assume you have two quantities A and B. Two quantities A and B. These are two different quantities. So when we talk of direct variation, this is how you represent it. This is a symbol for variation. This kind of alpha like symbol. So how do you read this? You say A varies directly as B, or A is directly proportional to B. That's how you read this out. Yes. So And if you say A is directly proportional to B, you can also write it as B directly proportional to A. That's what I mean. Whether you mention A first or B first, that's the relationship between them. And what this means is whenever there's an increase in A, there will also be a corresponding increase in B. Now this increase can be that maybe if A increased by 2 steps, B may increase by 3 steps or by 1 step, but there must be a corresponding increase. Now the magnitude of the increase that will be causing B will be determined by what is called constant of proportionality, as we are going to look at very soon. Now when you find yourself in this situation, what do you do next? This is a mathematical statement. A directly proportional to B is a statement. It's not an equation. So we need to convert this to an equation for us to now be able to do calculations on them, assign values, read numbers to them and do calculations. So how do you do that? Whenever you have to change this proportionality sign to an equality sign, this equality sign, why this is proportionality sign, you have to introduce what is called a constant of proportionality. Usually in mathematics we use K. We use K to represent the constant of proportionality. So we'll say A now equal to KB, K times B. Yes. So this is how you convert the proportionality sign to an equality sign. So the next thing you do is, like in the question, they will now give you values of A, initial values of A, initial values of B, which you now enter into the equation to solve. So when you take a real life problem, you will understand better what you do next from here. So we have some illustration. You say A very directly as the square of B. I can say it here, A directly proportional to B squared. That's what the interpretation of this statement. Then when you change this from proportionality sign to equality sign, you have what A equal to KB, where K is constant of variation or constant of proportionality. As you can see here, it's where K is constant of proportionality or constant of variation. Number two says B varies directly as the square root of Q. Now this is what it means. P varies directly as the square root of what? Q. Then when you change it to equation, you have this. Yes. Then you can now see a real practical example. Example one, you say what? If P varies directly with Q. So in this problem, what do you do first? You establish the relationship between P and Q. P varies directly as what? Q. From this statement that tells you the relationship, the connection between them. You now said Q equal to 2 when P equal to 10. So you carry these two initial values, put it inside here after you've converted it from statement to an equation. So you put those two initial values inside here to calculate your K. So Q equal to 2 when P equal to 10. So I put 10 here in place of P, then 2 in place of Q. That's how we got 10 equal to 2K. Remember, K is constant of proportionality. From there, you get K as what? 5. This is the first thing you do whenever you come across question on variation. You use the initial values to calculate your what? Constant of proportionality. So once again, when you come across a question on variation, the first thing to do is to establish the relationship. And usually the first sentence or four part of the question will try to tell the relationship that exists between the quantities. In this case, the two quantities under consideration are P and Q. P and Q. And it says P varies directly as with Q. What this means is what whenever there's an increase in P, there will be a corresponding increase in Q. And this is the mathematical statement. P varies directly as Q, or P directly proportional to Q. And as we already learned, the next thing to do is what? Convert this mathematical statement to an equation. And whenever you do that, you must introduce a constant of proportionality. So this equal to and K replaces the what? This proportionality sign. Then the second part of the equation will give you the initial values for P and Q. Like saying, okay, when Q equal to 2, P is equal to 10. So these initial values, you put it into this equation. That's why here we see what? In place of P, we are putting 10. And in place of Q, we are putting 2. So K times Q, that means K times 2 will give us 2K. Then divide both sides by what? Since we are looking for K, divide both sides by 2. You see K will be equal to 10 over 2, which is giving us 5. So this is what is called the equation of relation. So after getting K now, what do you do next? You take this value of K and put it back inside this original equation, the first equation you got from the statement. So since I got K to be equal to 5, my equation of relation now will be P equal to, in place of K, I'll put 5, 5Q. So this is what is known as the equation of relation. Yes, or the equation connecting P and Q. So in simple interpretation, this means to get the value of P, you have to multiply Q by 5. Yes. To get the value of P, multiply Q by 5. So let's go back to answer the question. I say what? Find P when Q is equal to 5. So I can say when Q equals 5, I go back to the equation to this equation. So every other thing you are solving, once you have established this equation now, every other thing you'll be solving, you'll be making use of this what equation. So you say we should find P when Q equal to 5. But the formula says P is equal to this formula now. P equals 5 times Q. So in essence, it means P, when Q is 5, P will be equal to 5 times 5. And of course, that will give us 25. Yes. So this is how you solve problem on variation. So look at more examples. Consider the answer here. Let's look at example 2. It says, if x minus 3 is directly proportional to the square of y. So you've used this now. Let me just put a kind of comma here. This spells out the relationship, tells us the relationship between x and y. So x minus 3, he says directly proportional to square of y. So that is y squared. So we have established the relationship between x and what? Y. The next thing we expect is what? The initial values of x and y. By the way, before then, we need to convert this to an equation. So we need to change it to what? Equation. So this equal to and k combined together replaces the this proportionality sign. So we have x minus 3 now equal to k times y squared. So the initial value that will give it to us now, that's the next thing we expect after establishing this relationship. Initial values of x and y we put inside this equation to get the value of k. So let's go there. It says x equals 5 when y equals 2. X equals 5 when y equals 2. So x equals 5 when y equals 2. So I'll come back to this equation now. Anywhere we see x, we put 5. Anywhere we see y, we put 2. So let's go there. So x, sorry, instead of x now, I'll put what? I'll substitute the value. That's what I'm supposed to do. So here now, instead of saying x minus 3, I'll say 5 minus 3. 5 minus 3 in place of x minus 3, right? Because x equal to 5 equal to k times, no, ky squared means k times y squared. Now, we're given that y is equal to 2. When x is 5, y is 2. So I'll now say 2 squared. So, um, 5 minus 3 is what? 5 minus 3 is 2, right? Equal to 2 squared is 4. So 4 times k will give us 4k. So to get the value of k, divide both sides by 2. So 2 over 4 will be equal to what? K. So k equal to 2 over 4, which is 1 over 2. So k equals 1 over what? 2. So this is how they got the value of k here, 1 over 2. Now, having gotten the value of k, what do we do next? Take this value of k and insert it into here, to this equation. Insert it here. So this implies that x minus 3 equals ky squared. So x minus 3 equals, place of k will put what? Half, right? Because k equal to half. 1 over 2 times y squared. So x minus 3 equals y squared times 1 will give us what? Y squared over 2. Y squared over what? 2. So this is our equation of relation or formula connecting this and this. You can see it here now. This and this are the same. So having established this formula now, any other thing we'll be solving going forward, we'll be making use of this formula. We'll be making use of this formula going forward in any other thing we'll be solving. So going to the main question now. Remember, if you get this formula wrong, any other thing you'll be doing will also be wrong. And sometimes in the exam, what they may even ask you is to establish this formula. So in continuation of the question, it says find x when y equal to 6. So I'll say when y equals 6, remember here it says x minus 3, x minus 3 is equal to y squared over 2. So we're looking for x, find x when y equals 6. So now say x minus 3 is equal to, in place of y squared, I'll put 6 squared, equal to 6 squared all over 2. 6 squared is 36, and 36 over 2 will be 13. No, 36 over 2 will be 18. So x minus 3 is equal to 18. So x will be equal to 18 plus 3, and that will give us what now? 21 as our final answer. Yes. So that's how you go about solving this. And this something like this is a common question in your exams, which you have to look out for. So that's how this is solved. I have class exercise which you are expected to solve. Number one says x is directly proportional to y. If x equals 5 when y equals 3, find y when x equals this. So you should be able to solve this. I believe you should be able to. Number two says the wages of a laborer varies directly as the number of hours worked by the laborer. So the laborer earned 500 when he worked for 2 hours. Then we now have the other questions. What do you do here? So in this kind of problem, maybe we first of all want to represent the wages. You can use letters to represent the wages. So like here I can say, I'm not going to solve it in full, but let me just give you a little tip of what to do. You say the wages of a laborer. So I can say let W equal to wage and L, the wages of a laborer varies directly as the number of hours. So let me just say H. Let H equal to number of hours equal to hours the laborer worked. So I'll define these two variables now. So let's establish the relationship between W and H, which is the wage and hours worked. So he said the wages of a laborer varies directly. So directly means this is direct proportion. This direct variation. Another way you can say is what? The wages is directly proportional to number of hours worked. That will still be saying the same thing. So what this means is what? W, which is the wages, is directly proportional to H. Remember, I can use any letter of your choice to as variable in this case. So W is directly proportional to what? To H, which is hours worked by the laborer. Then what do you do next? Change this to equation, right? This is a statement. Change it to equation by saying W equal to KH. What are we expecting next from the question? The initial values of W and H to enable us to calculate K. So it now says the laborer earned 500. That is the wage now. When he worked for 2 hours. So what this means is W equal to 500 naira when H is equal to 2 hours. Because once again, he earned 500 when he worked for 2 hours. So with these two initial values, we use it to get put inside here to get the value of K. Put inside there to get the value of K. So that means um, W equal to KH. So K will be equal to divide both side by H equal to W over H. Yes, because I'm trying to make K subject of formula now. So making K subject of formula means K will be on one side, then the other things will be on the other side. I believe you understand this, how to make simple subject of formula. So this will be equal to, remember our W for the initial value is 500, then over 2. 500 over 2. And that will give us 250, 250. Sorry, 250. I wrote and wrote 2,500, 250. So having got to the value of k to be 250, what do we do next? We'll take this value of k back to this equation. So that now means W will be equal to, in place of KH now, we now put 250H. 250H. This becomes our equation of relation. Okay, finish up from here. We said find the the amount he will earn if he worked for 7 hours. So H is number of hours, right? So just put 7 here. So you will earn 250, which is K now, times 7 hours. That will give you a value of W. And I said the number of hours he would work if he is paid 800. So in this case now, the W is 800. You put it here, then you now calculate for H. And that's how you go about solving this. So let's proceed. Okay, we'll go straight to the second type of variation, which is inverse variation. Inverse variation is almost like opposite of direct variation. Remember in direct we said if two quantities are in direct variation means if there's an increase in one, there also be an increase in the second one. And if there's a decrease in one, it also causes a decrease in the second one. That is when we talked about direct variation. Now we're looking at the second type of variation, which is called inverse variation. In this case, an increase in one will cause a decrease in the other one. Yes. So when you are considering two quantities, if one increases and the other one decreases, an increase in one causes a decrease in the other one, it means the two quantities are in inverse. Inverse like opposite, inverse variation. So here it said consider two quantities, x and y. If when one increases, of course, as I said earlier, the other one decreases, that means they're in what? Inverse variation. And how do you represent it? If I'm considering two quantities like x and y, so I can say x. Remember, this is a symbol for variation, right? 1 over y. This is the inverse now. For example, to take the inverse of a number, it means 1 over that number. Yes, so this is how we represent inverse variation. So you can read this as x inversely proportional to y, or x varies inversely as what? Y. This also implies that this also implies that y varies inversely as x. So either of these are the same. So once again, an increase in y will cause a decrease in x and vice versa. Then similarly, what do you do next? You change this to an equality sign. You now give us y, okay, x, and use this x equal to k times 1 over y. So x equal to k times 1 will give us k over y. So that's how you change this statement to an equation. So I have some illustration here, which I'm going to run through quickly before we now take more interesting questions. Here, so a varies inversely as the cube root of b. A varies inversely as the cube root of b. How do you represent this? A varies as the cube root varies inversely. Inverse means 1 over cube root of b. So the correct way to write this cube root is what? The 3 should be inside the root angle. So if we change this to equation now, we now have a equal to k times 1 over cube root of b. So a equals k times 1 will give us k all over cube root of b. So that's what you do in this case. The second illustration says p varies inversely as the square of q, and that's what you have here. Inverse means 1 over the square of q. So we proceed. Let's take some calculation on inverse variation. So in this example, it says t is inversely proportional to d and t equal to 0.15 when d equal to d. So instead of giving you this statement in words, they gave it to you already in mathematics. So they gave you the statement in mathematics. Then these are the initial values. T equal to 0.15 when d equal to 120. Now say find t when d equal to this and also what d when t equal to this. So all you do next is change this mathematical statement to an equation. Already you already know how to do that. So t inversely proportional to 1 to d, and that become t equal to 1 k over d. Yes, I believe you understand that because we've done that before. So from there, you put in the initial values and you get your k. So instead of now writing t equal to k over d, now become t equal to 18 over d. Why? Because k is calculated to be 18. Then from there, this is the formula you'll be using going forward now. In solving the A and B part, the main question, this is the formula you'll now be using. I think the A part says you should find t when d equal to 45. You can see it here. This is the value of k. 18 is k. Then 45 is d. Then the other one too. I believe you understand that. If you don't, then you can ask question. Another example is if p is inversely proportional to the square root of q and p equal to 3. So this tells us the relationship between p and square root of what q. And that's what you have here. This is the interpretation of that statement. P inversely proportional to, inverse means 1 over, right? Then square root. Make sure you understand the wordings, everything I said here. Square root. Square root is square root of q. Then use the initial values, put them here, and you what? Do your calculation. Yes, it's clearly explained in the note here. It's clearly explained. If you have any ambiguity, you can ask question. Using all the what appropriate channels. This is also explained. Okay, let's look at the class exercise. Number 1 says if x varies inversely as the square root of y and x equal to 8 when y equal to 4, find y. They should be able to solve this. Yes. Let's look at number 2. Anyone I see that maybe had some things that may confuse you other than what you have explained already, then I will give you some hint or solve it for you. That's my target right now. So if y varies inversely as x, this is the relationship y varies inversely as x. It now says we're given the initial value of y and x. Say find the law of variation. Yes, this and this. So what's the law of variation? Is what I've been calling this as what equation connecting the two variables. So let's go there. Let me just do this quickly for you. At least the first part of the question. Y varies inversely as x. So it means y is inversely proportional to x. So y is equal to k over x. You know why? Because whenever you are changing this to equality sign, you have to multiply the right hand side by a constant of proportionality known as k. Then y equal to 6 when x equal to 2. So in place of y, I put 6 equal to k over 2. So cross multiply, right? So I'll have k to be equal to 12 because this is over 1. K times 1 will give me k. 6 times 2 will give us what? 12. So having gotten the value of k, what do I do next? I take this value of k and put inside this here to get what is called the law of variation. So the law of variation is this now. Y equals, in place of k, I'll put what? 12, right? 12 over x. So this is the law of variation. Yes. So another thing you're solving going forward, you're going to be using this law. Like the second part say what? You should find x when y equal to 10. So when y equal to 10, so you put 10 here, then from here you find your what x. The second one say find y when x equal to this. So yeah, you can do that. I trust you very much that you can do that. So far we've looked at direct variation and inverse variation. The next will be joint variation.